Andarki namaskaram. In last video we have seen different types of numbers in number system such as natural numbers, whole numbers, integers, rational numbers, that is p by q form, and irrational numbers and real numbers in number system. In today's class, let us see how to represent rational numbers on the number line. Before going to today's topic, let us see answers for homework given in last video. First, filling the blanks. First one, the set of numbers 0, 1, 2, 3 and so on are called dash numbers. Answer is whole numbers. Rational numbers are represented by dash r or q. Answer is q. 0 is neither positive or nor negative. Fourth one, root 17 is dash number. It is an irrational number. 17 is not a perfect square, so it is an irrational number. Fifth one, there is dash rational numbers in between any two rational numbers. Their answer is infinite. Sixth one, given a rational number minus 5 by 9, this rational number can also be known as dash. Minus 5 by 9 ని రేషనల్ నంబర్ అంటాం. దీన్ని ఇంకొక పేరుతో కూడా పిలవచ్చు. అదేంటి? ఇక్కడ ఇచ్చిన ఆప్షన్స్ హోల్ నంబర్, రియల్ నంబర్. హోల్ నంబర్ ఫ్రాక్షన్ ఫామ్ లో ఉండదు. రియల్ నంబర్, ఇట్ ఈస్ ద కాంబినేషన్ ఆఫ్ రేషనల్ అండ్ ఇర్రేషనల్, సో ఆన్సర్ ఈస్ రియల్ నంబర్. సెవెంత్ వన్, ఎవ్రీ రేషనల్ నంబర్ ఈజ్ ఏ హోల్ నంబర్. ఆన్సర్ ఈజ్ ఫాల్స్. ప్రతి రేషనల్ నంబరు హోల్ నంబర్ అవ్వదు. ఎందుకనంటే 5/7 అనేది రేషనల్ నంబర్. ఒక ఎగ్జాంపుల్, 5/7 is a rational number but it is not a whole number. Eighth one, smallest natural number is dash, it is 1. Ninth one, 25/0 is dash. Already we have discussed in last video, division with 0 is not defined. Such numbers does not exist, so answer is not defined. 10th one, 0/1 is dash. Answer is 0. 0 by any number is 0. Now let us see the second question. In that, first one is write any three rational numbers. Also explain rational number in your own words. Explain rational number in your own words means you need to write the definition or write in your own words itself, but without changing the meaning of the definition, and with three examples. Next, so here three rational numbers are given as 2/3, minus 7/5, 9, and the definition as the number which can be written in the form of p by q, where p, q are integers and q not equal to 0 is called a rational number. Second question, categorize 7, 3/2, 0, 2, minus 9/5, 1/4 and minus 8 as natural numbers, whole numbers, integers, రేషనల్ నంబర్స్. ఇక్కడ ఇచ్చిన నంబర్స్ని వీటిలో ఏవి న్యాచురల్ నంబర్స్ అంటారు, ఏవి హోల్ నంబర్స్ అంటారు, ఇంటీజర్స్ అంటారు, రేషనల్ నంబర్స్ అంటారు, 4 గ్రూప్స్గా డివైడ్ చేయండి అని అడిగాం. సో ఇచ్చిన నంబర్స్లో ఫస్ట్ వన్ న్యాచురల్ నంబర్స్. న్యాచురల్ నంబర్స్ ఆర్ 2 and 7. నెక్స్ట్ హోల్ నంబర్స్ 0 to 7. ఇంటీజర్స్ ఆర్ 0 to 7 minus 8. నెక్స్ట్ లాస్ట్ వన్, ఫోర్త్ వన్, రేషనల్ నంబర్స్. Here all natural numbers, whole numbers, integers, all will come under rational numbers. So all the given numbers will be rational numbers here. Next, third question, give one example each to the following statements. కింద ఇచ్చిన స్టేట్మెంట్స్ అన్నిటికీ కూడా ఒక్కొక్క ఎగ్జాంపుల్ రాయాలి. ఫస్ట్ ఏ నంబర్ విచ్ ఈజ్ రేషనల్ బట్ నాట్ అన్ ఇంటీజర్. ఒక నంబర్ రేషనల్ అయి ఉండాలి కానీ ఇంటీజర్ కాదు. ఎగ్జాంపుల్, ఫ్రాక్షన్స్ 7/4, దోస్ ప్యూర్ ఫ్రాక్షన్స్, దోస్ ఆర్ రేషనల్ బట్ నాట్ integer. B, a whole number which is not a natural number, that is whole numbers లో natural number కానిది ఏది అని అంటే 0. C, an integer which is not a whole number. Here you have different, so here I have given my negative natural numbers, those will not be whole numbers. So -1, -2, -3 and so on. Next, D, a number which is natural number, whole number, integer and rational number. Those are nothing but natural numbers. Natural numbers మాత్రమే whole numbers లోను, integers లోను, rational numbers లోను ఉంటాయి కాబట్టి వాటిని అన్ని నేమ్స్ తో పిలవచ్చు. సో 1, 2, 3 and so on. E, a number which is an integer but not a natural number. Integer అయి ఉంటుంది కానీ natural number కాదు. So those are nothing but all the 0 and all the negative natural numbers. This is about the homework. So children, in last video we have some different types of numbers such as natural, whole, integers and real numbers. Today let us see how to represent those numbers on the number line. For example, if we take natural numbers on the number line, those will be like this. So 1 is the initial point. When 1 is added to 1, we get to 2. 2 is the successor of 1, whereas 1 is called predecessor of 2. So 1 is added to 2, we get 3. If we add 1 to 3, we get 4. Like this numbers continues 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. So here if we see this one, we are saying it as number line, but it is not number line. Line means both side arrow mark will be there. Here if we see only one side, this side we don't have arrow mark, the other side arrow mark is there. So 1, before that we don't have any natural numbers, but after 9 the numbers continues, uncountable numbers continues, that indicates by arrow mark. So there is a meaning for arrow mark on the number line. Similarly, if we take whole numbers, so here in natural numbers 1 is the initial point, in whole numbers 0 is the initial point. In the same, similar to natural numbers, here also when 1 is added to 0 we get 1, when 1 is added to 1 we get 2. Like this the numbers continue. So one side arrow mark will be there. If we see right side we have arrow mark, whereas left to 0 we don't have any arrow mark. If we see in the natural numbers, 1 is the smallest natural number, whereas highest number does not exist. In whole number 0 is the smallest natural number, highest number does not exist. What about the integers? Integers both sides continuous, positive natural numbers are there, negative natural numbers are there. So both sides on the number line we will have arrow mark on both sides. When we take integers on the number line, we take 0 in the middle. Right side of 0 there will be positive natural numbers, which are also called as positive integers. 1, 2, 3, 4 and so on. These are the positive natural numbers. On the other side we have negative integers, -1, -2, -3, -4 here and so on. So here arrow mark is there after -4. Here also after 4 we have arrow mark. So in this case we don't have smallest integer, we don't have highest integer, but we can say negative and positive integers are there. So what about the 0? 0 is neither positive nor negative. 0 అనేది positive కాదు, negative కాదు. And one more thing, if you observe these 3 number lines in between any 2 successive integers. Successive means side by side, continuous integers. For example, integer number line you see, in between 0 and 1 I don't have any other integer. If we take 0 and 2, I have one integer. If I take 0 and 10, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 integers. So what we can say is, in between any 2 integers we have countable, limited. Countable means which we are able to count. Countable or limited number of integers. But what about the rational numbers? If we take rational numbers on the number line, how those will be there? Those will exist in between this 0 and 1, 1 and 2 also. Here in between 0 and 1 we don't have any integers, but in between 0 and 1 we can have rational numbers. So let us see rational numbers on the number line. See this one, I have taken a number line with here all the rational numbers with denominator 3. If we see here, where are the integers? Integers are there, those are in the other form. 0 by 3 is 0, 3 by 3 is 1, 6 by 3 is 2. Like this integers are there in the other form. So here with in between 0 by 3 and 3 by 3, which is nothing but 0 and 1. In between 0 and 1 I have 1 by 3 and 2 by 3 rational numbers. In previous case we don't have integers, but here 2 rational numbers are there in between 0 and 1. Not only in between 0 and 1, 3 by 3 that is 1, 6 by 3 that is 2. In between those also 4 by 3 and 5 by 3 are there. Once again 2 rational numbers. So with the denominator 3, always in between 2 successive integers we have 2 rational numbers. What about if we take some other denominator 8? So here if we see 0, 1, so in between 0 by 8 is there. Immediately after that we can write how these numbers are written on the number line. Just observe, 0 by 8, next number is 1 by 8, next 2 by 8. So same denominator will be there, only numerators will be changed. So 0 by 8, 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, here 6 by 8, it is mistake. 6 by 4 is not correct. 6 by 8, 7 by 8, 8 by 8, 9 by 8, it continues like this. Where, so here in between 0 and 1 we have 1, 2, that is 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8. We have 7 rationals. In between 1 and 2 also we have 7 rationals. So if we increase the denominator, what will happen? In between 0 and 1, if I take 100 as the denominator, how many rational numbers I get? 99. Carefully observe. If we take the denominator 3, I have 2 rational numbers in between 0 and 1. If I take 8 as the denominator, in between 0 and 1 I have 7. So 1 less than the denominator. Those many rational numbers will be in between 2 successive integers. So if I take 1000, I will have 1 less than that, that is 999 rational numbers. So here we can say that in between any 2 rational numbers there exist infinite rational numbers. This property is called density property of rational numbers. Children, remember that number line can be written with a denominator 3 or with a denominator 2 or with a denominator 4 or with any denominator. Now let us move on to the today's topic, that is representation of rational numbers on the number line. So for this I am going to take a question here. Represent 5 by 3 and minus 5 by 3 on the number line. So children, you should know these numbers where in between 2 integers these 2 numbers lie. So 5 by 3, if we find the decimal value, this is 3 1 ja point, 2 will be left out, point is there. So 0, 20, 3 6 ja 18, once again 2 will be remained, 3 6 ja 18, 3 6 ja 18, it repeats. So 5 by 3 lies between 1 and 2. Similarly, minus 5 by 3, that is nothing but minus 1.66, it lies between minus 1 and minus 2. So to represent these numbers on the number line, I am going to explain you a very easy method. So take a number line. So in the middle I am taking 0, but here what is the denominator is there for both the numbers? 3. So I am writing 0 by 3. 0 can be written as 0 by 3, which is 0. Though immediately next number is 1 by 3. Next number 2 by 3. 3 by 3. 3 by 3 is nothing but 1. 4 by 3. 5 by 3. Here 6 by 3. 6 by 3 is nothing but 2. In the same way, left side of 0, we can write it as 0. 0 by 3. Next number is minus 1 by 3. Next number minus 2 by 3. Minus 3 by 3. Minus 3 by 3 means 3 by 3 is 1. This is minus 1. Minus 4 by 3. Minus 5 by 3. Minus 6 by 3. So here 5 by 3 and minus 5 by 3 lies between 0, 1 and 2 and minus 1 and minus 2. So we need to have minus 6 by 3 means minus 2. So on the number line we need to have these numbers such that we need to take the number line. So here if we see where is the 5 by 3? 5 by 3 lies between 1 and 2. So 1 we have written here, 2, 3 in between that. Is it there? Yes, this one. 3 by 3, 4 by 3, 5 by 3. So this is our 5 by 3. So A is equal to 5 by 3. Next, move on to next number, minus 5 by 3. It lies between minus 1 and minus 2. So minus 1 and minus 2, in between these two we have minus 4 by 3 and minus 5 by 3. This is our minus 5 by 3. Next, second number. So children, this is how we represent rational numbers on the number line in a easy. There is one more way to represent. So here also we find out the decimal value of 5 by 3, that is 1.66 and so on. It lies between 1 and 2. Similarly, minus 5 by 3, it is equal to minus 1.6 and so on. It lies between minus 1 and minus 2. We draw a number line. In the middle here minus 2 to 2 we need to have. So 0, left side minus 1, minus 2, right side 1, 2. So we need to take equal portions. So here 5 by 3, 3 is the denominator. It represents how many portions you need to have in between 0 and 1 or 1 and 2, and in between any two integers. How many portions? 3 is the total parts you need to divide. So here 5 by 3 lies between 1 and 2. So in between 1 and 2 I need to have 3 portions. 3 portions means how many lines I can draw? Equal portions I need to have. 1, 2. If I draw 2 lines, I will get 3 portions. If I draw 3 lines, I will get 4 portions. So 2 lines I have drawn. 1, 2, 3. 3 parts. So here this 1 can be written as 3 by 3. This is 6 by 3. So where is 5 by 3? 6 by 3 is nothing but 2. So where is 5 by 3? Immediate after 3 by 3, what will be repeated? 4 by 3. This is 5 by 3. This is our A. 5 by 3. Similarly, minus 5 by 3 lies between minus 1 and minus 2. So in between minus 1 and minus 2, here denominator is 3. This portion should be divided into 3 equal parts. How many equal parts? Denominator is 3 equal parts. So to get 3 equal parts, I need to draw 2 lines dividing the portion into 3 equal parts. 1, 2, 3. 3 parts. Now minus 1 means minus 3 by 3. Minus 2 I can write it as like this, minus 6 by 3. So mark the numbers here. So immediate after minus 3 by 3, here minus 4 by 3, and next number is minus 5 by 3. So this is our second number, B. So like this also you can represent rational numbers on the number line. You can choose the first one or. Now let us see how to represent 5 by 8 on the number line. So 5 by 8 is nothing but, it won't go with 5, 8. So it will be 0.50. 50 means 8 6 ja 40. It and so on. Okay. Approximately 5 by 8 lies. Approximate value of 5 by 8 is 0.6. So it lies between 0 and 1. So let us draw a number line. 0, 0, 0. Here what is the denominator? 8. So 0 can be written as 0 by 8. The next number is 1 by 8, 2 by 8. Next rational number is 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, 8 by 8. So 8 by 8 is 1. So where is our 5 by 8? 1 by 8, 2 by 8, 3 by 8, 4 by 8, 5 by 8. Here this is our 5 by 2, 5 by 8. Here 5 by 8 means here total, the portion between 0 by 8 and 8 by 8, that is the portion between 0 and 1 is divided into 8 equal parts. 8 is the denominator. If you can see here 1, 2, third portion, 4th, 5th, 6th, 7th, 8th. By drawing 7 small lines, you got 8 portions. So out of total portion, 5 by 8 means 5 portions you need to take. So 1, 2, 3, 4, 5. 5 portions. So this indicates the fifth part of the total portion in between 0 and 1. So children, here in between 0 and 1, how many rational numbers are there? 1, 2, 3, 4, 5, 6, 7. Okay. With the denominator 8, we got 7 rational numbers. In the previous question, with the denominator 3, we got 2 rational numbers. Means denominator, whatever denominator is there, 1 less than that. Those many rational numbers exist between any two integers, not only 0 and 1, even after 1 and 2 also the same starts. So here if I increase the denominator, instead of 8, if I take 100, I will get 99 rational numbers. If I take 1000, I will get the 999 rational numbers in between 0 and 1. So if I increase more denominator, then I get more and more rational numbers in between any two integers. So here this property means we can say that there exists infinite rational numbers in between any two rational numbers. This is called density property of rational numbers. It is not same with the integers. If we see in between any two integers, that is 0 and 2, I have 1. If in between 0 and 1, I don't have any integer. In between 0 and 10, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 integers. So in between any two integers, I have limited number of integers, but it is not same with rational numbers. In case of rational numbers, in between any two rational numbers, there exists infinite rational numbers. Every point on the number line, every small point on the number line denotes a small rational number. So here there exist infinite rational numbers in between any two rational numbers. This property is called density property of rational numbers. So children, just now I said that there exist infinite rational numbers in between any two rational numbers. Now here I have given two rational numbers. See this question, find two rational numbers between 3 and 4 by mean method. So between 3 and 4, I need to find out 2. How many I will have in between any two numbers? Infinite. Out of those, only 2 are required. And here we need to find out those two rational numbers by using mean method. So what is mean? Mean is not mean. Other name of mean is average. So that is nothing but sum of the quantities divided by total number of quantities. So here 3 and 4 are two numbers. So total number of quantities are 2. So sum of quantities means 3 plus 4. So here mean definition is mean of, if there are two numbers A and B, mean of A and B is A plus B, that is sum of quantities divided by 2. So here why mean method we are using? If I take mean value of 3 and 4, that is the mid value of 3 and 4. On the number line, if I have 3 and 4, the mid value is nothing but the mean. So I am using mean here. In the same way, if I find out mean of 3 and 4, that is 3 plus 4 by 2, that is equal to 7 by 2, that is equal to 7 by 2, that is equal to 3.5. So 3.5 definitely it lies between 3 and 4. It lies between 3 and 4. Now I wanted to have one more number because they are two rational numbers. So now if I find out mean of 3 and 3.5, that lies between 3 and 3.5, mid value of 3 and 3.5. Or I can find out the mid value of 3.5 and 4, that is here. Any one. I am finding here mean of 3 and 3.5, that is sum of quantities divided by total quantities. Total quantities are 2. 3 plus 3.5 is 6.5, that is divided by 2. If I divide with 2, I will get 2 3 ja 6, 2 2 ja 4, 2 5 ja 10. So 3.25. So 3.5 comma 3.25 are two required rational numbers in between 3 and 4. So if instead of two rational numbers, if 10 rational numbers are asked, we need to continue in the same way. But this process become lengthy. So we need to have some other shortcut method. Let us see next question just by small technique or logic. So children, I have given a question here. Find 5 rational numbers between 1 and 2, 1 by 3 and 5 by 3. Third, minus 1 by 5 and 1 by 2. No denominator. If no denominator means 1 is the denominator. 1 can be written as 1 by 1. 2 can be written as 2 by 1. 1 by 3 and 5 by 3. Same denominator are there. Minus 1 by 5 and 1 by 2. Different denominators are there. These are the 3 types of questions you will get in the test book. So here if you observe, I have not asked to find out 5 rational numbers by mean method. So some other, let us do this one by a small logic and in easy way. So first one I am taking 1 and 2. In between 1 and 2, I need to find out 5 rational numbers. How many rational numbers? 5. So I am using the logic. Here 5 are asked. I am adding 1 to 5. I am adding 1 to 5, I will get it as 6. Now 1 can be written as 1 by 1 can be written as 1 by 1. Now I am multiplying with the 6 in the denominator as well as in the numerator. Now I will get it as 1 into 6 is 6, 1 into 6 is 6, 6 by 6. 2 can be written as the same way, 2 can be written as 2 by 1. With the same 6, I am going to multiply in the numerator as well as in the denominator. 2 into 6 is 12, 1 into 6 is 6 in the denominator. So here 6 by 6 and 12 by 6 are the other forms of 1 and 2 only. These two other forms will help us to find out how many rational numbers are there in between 6 by 6 and 12 by 6. You know, if we represent these numbers on the number line, 6 by 6, somewhere 12 by 6, this is 1, this is 2. So after 6 by 6, what will be there? 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6, then 12 by 6. So you know the answer. So number line is not required to draw here. So let us write the numbers here. So 7 by 6, 8 by 6, 9 by 6, 10 by 6 and 11 by 6. 1, 2, 3, 4, 5. So we got 5 rational numbers in between 1 and 2 are required 5. So here we have taken 5 plus 1, that is 6. We have multiplied with 6 in the numerator and also in the denominator we have multiplied with 6. So I got 5 required rational numbers. Let us move on to the second one, 1 by 3 and 5 by 3. 1 by 3 and 5 by 3. If the same denominator is there, we use the same technique as we used in the previous one. So here also both of them are having the same denominator 1. Like this only it also can be done. So here 1 by 3, 5 rational numbers are asked. So 5 plus 1, that is 6. With the 6 I need to multiply in the numerator as well as in the denominator. In numerator as well as in the denominator. So in the numerator I get 1 into 6, 6. In the denominator I get 3 into 6, 18. In the similar way, 5 by 3 can be written as with, I need to multiply with 6 in the numerator, in the denominator. What I will get? 5 6 is 30, 3 6 is 18. 5 6 is 30, 3 6 is 18. Now see, both of them are having the same denominator 18. If I represent these numbers on the number line, after 6 by 18, what is the number? Next number will be there 7 by 18. Next 8 by 18. So how many will be there? 7 by 18, 8 by 18, 9 by 18, 10 by 18, 11 by 18, 12 by 18, 13 by 18 till I can write 30 by 18. Here in the question they asked between. Between means మధ్యలో అన్నప్పుడు ఇవి రెండు తీసుకోకూడదు. 6 by 18, 30 by 18 రాయకూడదు. వాటి మధ్యలో ఉన్నవి మాత్రమే రాయాలి. కాబట్టి 7 by 18 నుంచి 29 by 18 వరకు రాసుకోవచ్చు. So here they asked only 5 rationals. I am writing only 5 out of those. 7 by 18, 8 by 18, 9 by 18, 10 by 18 and 11 by 18 are 5 required rationals. So I got 5. Okay, children, understood? Let us move on to the third question, that is minus 1 by 5 and 1 by 2. Here different denominators are there. So in this case, how to find out 5 rational numbers? Now let us see. So third question, minus 1 by 5 and 1 by 2, different denominators. If different denominators are there, if I multiply, 5 rationals are asked, 5 plus 1, that is 6. If I multiply, what will happen? Let us see. 6 by 6 in the numerator, in the denominator. Both in the numerator and denominator I have to multiply with 6. Here minus 1 into 6 is minus 6. Down 5 6 is 30. 30 is the denominator. Here in the other one, 1 by 2, 1 into 6 is 6. 2 6 is 12. 12 is the denominator. Just check the denominators. 30 and 12. If those numbers are taken on the number line, can I say what is the next number? I can say minus 7 by 30, but whether it lies in between these two, I don't know. So with the different denominators, I can't say whether that number exists in between those two rationals or not. So here directly with 6 by 6 I cannot multiply. So something else should be done here. So let us see what should be done. See the denominators 5 1 2, take the LCM of those. 5 1 2 LCM is 5 1 ja 5, next 2 1 ja 2. So 5 2 ja 10. LCM is 10. So here that should be the denominator, 10 should be the denominator for both the given rational numbers. So minus 1 by 5, to get the denominator 10, here 5 is there, with which number if I multiply I get 10. If I multiply with 2, 5 2 ja 10, but minus 1 by 5 should not change. So in the numerator also with the same number I have to multiply. So minus 1 into 2, that is minus 2 in the numerator. Next 1 by 2. So here in the denominator 2 is there, LCM is 10. To get LCM 10 in the denominator, 2 should be multiplied with which number? 5. 2 5 ja 10. Now with the same 5 I need to multiply in the numerator also. 1 into 5 is 5. So here 5 by 10. If I see here minus 2 by 10, 5 by 10, both of them are with the same denominator. Sometimes without multiplying with 6, here 5 rational numbers are asked, so 5 plus 1 6, 6 by 6 we have multiplied in previous questions. Here also we need to do, but before doing that sometimes we get 5 rational numbers here itself. Just check in between minus 2 and 5, minus 2 by 10 and 5 by 10, I have minus 1 by 10, 0 by 10, that is 0, 1 by 10, 2 by 10, 3 by 10, 4 by 10. So 1, 2, 3, 4, 5, 6. So 6 rationals are there. Out of those 5 can be written. But just imagine, instead of 5 rational numbers, if 10 rational numbers are asked in between minus 1 by 5 and 1 by 2. Here only we have 6, but I can't write 10. So in this case, sometimes depend on the question, we won't get the rational numbers in between these. So this step also is not enough. So what I do is, I will take minus 1 by 5, 1 by 2. Okay. Here LCM is 10. To get 10 in the denominator, I need to multiply 5 with 2. With the same number I need to multiply in the numerator also. So here 5 rational numbers are asked. So with which number I need to multiply? In the numerator and denominator, that is 5 plus 1, 6. So in the numerator and in the denominator I need to multiply with 6. So how much I will get? Minus is there, so minus 1 into 2 6 ja 12 divided by 5 2 ja 10, 10 6 ja 60 in the denominator. Same with the other number, that is 1 by 2. To get LCM 10 as the denominator, I need to multiply denominator 2 with 5 with the same 5 in the numerator. Here 5 rational numbers are asked, so 5 plus 1 6. With 6 I need to multiply in the denominator as well as in the numerator. So if I multiply these 3 numbers in the numerator, I get 1 into 5, 5 into 6, 30. Then 2 into 5, 10, 10 into 6, 60 in the denominator. Now if I see minus 12 by 60, 30 by 60, same denominator is there. So I will get 5 rational numbers in between these by using this step. That is, first step, get the LCM as the denominator. Then 5 rational numbers are asked, so with 6 by 6. So here I can write 5 rational numbers. Here 30 by 16 minus 12 by 16, here between us. So these two cannot be taken. In between means just before 30 by 19 is 29 by 60. Then 28 by 60. Just before that 27 by 60. Just before that 26 by 60. and 25 by 60 are 5 required rationals, I can write minus 12 by 60, just before that minus 11 by 60, minus 10 by 60, minus 9 by 60, minus 8 by 60, minus 7 by 60 also I can write. Those 5 rationals also I can write, or any 5 rational numbers I can write in between these. Here, so children, I think you understood. So here 5 rational numbers are asked, so we have taken 5 plus 1, 6. What happens if we take 5 plus 2, that is 7, if we multiply both in the numerator and denominator, if I multiply with 7 by 7, what will happen? Yes, in this case also you will get 5 required rational numbers or more than that. Even not only 7 by 7, you can take, instead of 6 by 6, you can take 8 by 8, 9 by 9, 10 by 10 or 100 by 100. You get more and more rational numbers in between them. Okay, but what happens if you take less than 5, that is 4 by 4, 3 by 3, 2 by 2 and 1 by 1, and if it 1 by 1 is nothing but the same number. So if we take 2 by 2, 3 by 3 and 4 by 4 and multiply both in the numerator and denominator, these 5 rational numbers are asked. So how many are asked, those many you may get or may not get in between them, in between the two given rational number. So less than the required rational numbers we don't take, we will add 1 or we add 2 or we add 3, and with that number we multiply in the numerator and denominator. This is the small technique. So here in between two rational numbers, how many rational numbers are there? Infinity. This is called density property of rational numbers. So in today's class we have seen two types of problems. One is representation of rational numbers on the number line. The second one is finding the required rational numbers in between two given rational numbers. Children, take today's homework, note down in your notebook, write the answers. So first question, write the greatest negative integer is dash. Second one, every dash number is a whole number. Third one, write 2 in p by q form at least in 2 ways. Fourth question, write 4 rational numbers between 2 by 19 and 7 by 19. Fifth question, write any two integers between minus 2 and minus 6. Sixth one, find 6 rational numbers between 2 and 3. Seventh, find 3 rationals between minus 1 by 4 and 1 by 4. Eighth one, find 3 rational numbers between 3 by 5 and 2 by 3. Ninth one, represent 8 by 5 and minus 8 by 5 on the number line. 10. Represent 1 by 11 on the number line. So children, this is about today's class. To write the notes from the given video, keep in pause mode and note down. In next class, let us see more about decimal. So thank you children. Thank you all. Stay home and stay safe.